always say something like
It's okay, yeah. All right, so here we go. So we're going to do part of this, and then we'll kind of be done with it, and then we'll start again next class. Okay, unit circle. All right, well, unit is 1, okay, typically. We used to call back in the day, and back when math was, like, easy, you used to call, you had your units, you had your tens, you had your hundreds, remember those? Okay, unit was ones, also known as 1. So unit is still 1. The unit circle is a circle of radius 1. There you can see this is 1. Of course, this would be -1, up 1, and down -1. So the circle centered around my origin, okay? Point P is somewhere along there, okay? In this case, I just randomly put it in the first quadrant, okay? The point P says it's at X, Y, all right? The radius, of course, is always going to be 1, okay? So I think you'll recognize these first 3. We're calling theta this little angle guy in here, okay? We talked about that last time. Theta is just another letter for angle, but it's a pretty common one, so we'll probably stick with that. Okay, so sine is what? According to that, remember we're probably going to be looking at this old friend. Remember him? Right, Sokotoa friend? Okay, so sine is opposite over hypotenuse, SOH. So what would the sine of this theta be in terms of y, x, or r? Y over r, very good. Okay. I'm using r. Since r is 1, we could say that the sine of theta in a unit circle is y. Okay? All right. What's the cosine of theta? That's the CAH. X over R, since R is 1, the sine is, or sorry, the cosine is X, right? Okay. What about the tangent? Y over X. There's nothing we can do with that as far as simplifying, because R is not involved. Okay, you recognize those other 3 functions? No?
Isn't it like I know the last 2.
This is cosecant. Okay? This is secant. In South Dakota, we used to say secant. No, we say secant. Here in Kentucky, South Dakota, we said secant. But anyway, and this is cotangent. Okay, just like we used to say root. This is for roots.
You said root.
It says roof. When it's a roof, we say roof. Yes. Okay, so those are the 3.
What do you say for a dog?
For what?
The dog bark. The dog bark. Woof, woof.
I don't know. Woof, woof. Yeah,
Okay,
no,
rough.
yeah.
Well, I just thought you would mess up.
No. Okay, so see, all along I'm saying it right, and I say woof. Root, root, root. Right? All right. Cosecant. Now, they're in an order in particular because they are reciprocals of the one that they're beside. So, what is a reciprocal? It's not the opposite. Flip it around. So, it's 1 over the sine. Okay? So, if we are flipping y over r, what do we have? R over y, or 1 over y, if r is in the unit circle, which is makes it 1. Okay? Secant would be 1 over the cosine, and we have r over x, or 1 over x. Okay? Cotangent, 1 over tangent, which is, in terms of x and y, x over y. Now, here's what you're going to remember. Because there's going to be like, oh my gosh, I'm going to remember all these. Okay? I'm going to remember that these are reciprocals. I'm going to just look at this number and flip it around. I'm just going to look at this number and flip it around, look at this number and flip it around. I'm probably not going to remember this because it's kind of random. Okay? So, these 6 functions try to remember them. We always do sine, cosine, tangent, and that's why we remember sine, cosine, tangent, SOHCAHTOA like that. We put them in that order, and that way they make sense. And then we put these in this order so that we remember how they match up. The cotangent, the tangent's easy, but these, you think they're backwards because the co doesn't match with the other co. But you just get used to that, okay? So those are the 6 functions. That's all there are of the thing, the different ones that are named. That is, those are all the different 6 functions. Okay, so let's be more specific. Let's put -1/5, 2 radical 6, 5 on the unit circle. Okay. According to, here's my unit circle. Oh my gosh, what quadrant is point P in according to the SIGN signs? 2, right. -1/5, maybe this is, remember this is -1, so -1/5 be about right here, so that would be right here. So this is point P, okay? -1/5, 2 radical 6, 5. Left, up.
Not rise over run.
No,
Another run.
no. This is XY. X is negative, it goes left. Okay, so here we go. Sine theta, cosine theta, tangent theta. Right beside it, we have cosecant, secant, and cotangent. Okay, now here's what you don't want to ever get in the habit of is writing these functions without something behind them. Okay, they're a function. They're like something, squaring something. You wouldn't think of not putting the number that you're squaring in front of the square symbol. They're like a square root. You wouldn't put the square root without putting something under the square root. Same thing. So I don't want to see, and I'm going to remind you, I'm going to be looking, I don't want to see these not written. If you noticed, when I did it over here, I did, oops, I missed one. I did the theta over here, because they just really shouldn't be without just getting the habit. Okay, so sine of theta. Now, theta is, you said, in the initial position, terminal position. Here's your theta in that second quadrant, like you said originally. Okay, so that's your theta. All right, according to this triangle, this x is going to be, or sorry, this is y, 2 radical 6 over 5. And of course, this is going to be -1/5. Okay? So every time you grab that x, you're going to grab the negative with it. All right, so sine, we go back to SOHCAHTOA. We're doing opposite over hypotenuse, which is opposites.
Wait, your theta's on the wrong theta's not. There's not an opposite of your theta because there's
Okay, that's a very good point. Your theta is here, no question about that, right? But we're going to focus on this triangle right here. This would be called our reference angle. Okay? It's not the same, but that's where we have to put it in the second quadrant. If we change everything to the first quadrant to get, what happens is, you don't know this yet, but this angle right here, the reference angle, is going to be the same as this angle right here. So it's going to have, I did that back. You're going to have symmetrical 1/5 and 2 radical 6, 5. 1/5 would be right here, 2 radical 6. So you're dealing with this, but in order to deal with the -1/5, you got to leave it over here. But this right here, let's call it, I don't want to call theta because we already mentioned theta. Let's call it another Greek letter, nu, or alpha. Alpha. Okay, so this is alpha, this is guy right here. This is alpha also. So they're symmetrical, so they have the same x, y, and r variables, right? Okay, so that's what we're dealing with. Thank you for asking. Okay, so opposite over hypotenuse. What is that? 2 radical 6 over 5 over, which is,
Oh, you have to do -2.
well, don't we know it? The unit circle, it's 1, okay? So the sine of theta is really, what's 2 radical 6 over 5 over 1? 2 radical 6 over 5. And remember, we said, oh yeah, the sine is really the y value. You can remember that. That would be helpful. If you can't, you just go around it. And eventually you'll get it. Okay. Cosine. Cosine is adjacent over hypotenuse. Okay. Adjacent over hypotenuse is something over 1, negative 1/5. Negative 1/5 over 1 is negative 1/5. Remember, on the unit circle, yeah, the cosine is the x value. Okay? All right? Tangents, a little bit mix of the x and the y. It's y over x. So it is 2 radical 6 over 5 over 1, negative 1/5. So what does that simplify to be? Okay, keep going. Negative 2 radical 6. That's right. Good job. Okay? The 5's cancel each other out because basically we're going to multiply by negative 5 over 1 to get the thing simplified. That's gone. That's gone. We have the negative. Okay? So sine is the y value. Cosine is the x value. This is only on the unit circle, people. And this is y over x. Okay? All right, so cosecant, we're going to take this number, flip it around. Take this number, flip it around. Take this number, flip it around. Probably the simplified version would be better. And remember the whole, not supposed to have a radical denominator. Wasn't my idea. Somebody decided that was a bad idea. So when we flip this around, we're going to get 5 over 2 radical 6. Right? And what happens when we get rid of the radical on the bottom? We multiply by radical over radical. 5 radical 6 over 12. Can we simplify radical 6 and a 12?
No.
That's right. Read them up. 2 times 6 is 12. Remember, this is radical 6 times radical 6 is radical 36, which is 6. Okay, flip around the secant theta. That's easy job. What's the reciprocal of cosine? Negative 5. Okay, we flip it around negative 1/5. It's negative 5 over 1. Get rid of the 1. Flip around 2 radical 6.
Negative 2.
So 1 over 2 radical 6.
Wait, 1 or negative? It's negative because it's negative 2. So just the whole thing.
Right. Doesn't matter where you put the
I know,
negative.
you just didn't say.
Okay. Divide, multiply by radical 6. Negative radical 6 over 12. Okay? So those are your 6 values that we were looking for on the unit circle. Find the values of the 6 trig functions that correspond to B.
All right.
Okay? Got it? All right. Any questions on that? Okay. All right. Now, remember last class we had quadrant angles. So our first 2 examples were in a quadrant. We have quadrantal angles. Okay. We have never done the tangent, sine, cosine of 90 degrees, have we? Because your only experience has probably been geometry. Okay, now, you're about to start. Okay. These are all quadrantal angles. So, if we want to draw them, 0 degrees or 0 radians would be right here. Okay? It's not moving anywhere. Remember, we are on the unit circle. What's the ordered pair on this unit circle? What is the ordered pair?
1, 0.
1, 0. Okay. That means we know the sine, we know the cosine because we know the y and the x. We can figure out the tangent, we can figure out the cosecant find the cotangent. Are you ready? Okay, I'm going to pull this up here just. Okay, so that's the first thing is just like, okay, here it is, place it. Oh, all right, so here we go. Sine of theta. Theta is 0 degrees or 0 radians, however you want to look at it. Okay, so what? Let's do sine of 0. Sine of 0. Okay, if I write 0 and I put a degree sign, what am I talking about? Radians. Okay, what's the sine of 0? Sine of 0, remember, is
Wait, why isn't it?
the y value. Well, theta is 0. I just put it in its place. So it is 0. Okay? Cosine of 0 is tangent of 0 is, because it's 0 over 1, which simplifies, right? Okay? Did we lose anybody? All right, now I'm going to do, what's the reciprocal of sine again? Cosecant. Secant. And cotangent, sorry. Okay, and you're going to want to, you just want to, I have a tendency to put my 0 up here. It wouldn't matter because 0 degrees and 0 tangents, 0 radians are the same thing. Okay, so I'm flipping around 0. What happens? Can't do it. So what does that mean? Does not exist. That's right. You flip around 0 over anything, 0's on the bottom, you got a big problem. Okay, when you flip around 1, what do you get? Still 1. When you flip around 0 over 1, does not exist again. Okay? Now your calculator can tell you the same thing. If you're like, okay, is that right? Okay. Mode, I'm in radians. Okay? So let's make sure we're in radians. Just to double check here, we're in radians. Okay? That's kind of the default. Start trying to think in radians. I know it's going to be a process to do that because you've been doing degrees up to this point. All right, so here we go. Sine of 0. Sine of 0. That's 0 radians. 0. Cosine of 0. 1. Tangent of 0. 0. Now, those are the only 3 functions you're going to find here. Okay? You'll have to know, now inverse sine is not the same as cosecant, just so you know. That's what is above here. Yeah, they won't let me do it. The blue function is not cosecant. Oh, that's the same thing. No, it isn't. That's a total different function, inverse sine. Okay? That's the inverses that we've been talking about. So anyway, so you can check them out. Yes, ma'am.
Do you just always, like, I just take the product of, like, the sine and cosine and just switch it around and figure out what it is?
That's what you do.
Do not do like the original thing, like 0 over 1 would be your sine.
I think it's confusing when you don't have a triangle. So when the quadrantial angles, I just go with the ordered pairs. And you can do it. I just think it's confusing because you don't have a triangle. You don't really have it. Is that an opposite? Is that it's just confusing. Okay. So 90. Where's 90? Which is pi over 2. That lands here, right here. Okay. Again, we don't have a ever did we do. We did cosine 30. We did sine 60. And yes, that we could create ourselves a triangle, but how do I know? I'm just stopping right here. So what are my ordered pair? What's my ordered pair right there? 0, 1. Okay. So that means that sine of, I'll do degrees first, cosine of 90 and tangent of 90. What's the sine of 90? Remember, the sine is your y value. Okay, so what's the y value? What's the cosine value, which is your x? And 1 over 0 does not exist. Okay? All right, I'm going to do radians for the second trio there. Cosecant pi over 2, secant pi over 2, tangent pi over 2. All right. Okay, do those 3, and then we'll check them out in the calculator. Oh, sorry. There now. Okay, so that's how you find in your calculator cosecant. 1 over the sine of half pi. Did you get 1?
Yep.
Good, because 1 over 1 is still 1. Okay. No, I'm just double checking. I'm just saying if you really wanted to check them, that's how you do. Okay, how would I plug in secant? 1 over cosine of pi over 2. Actually, use the pi key. Okay, if you're in degrees, then you can do 90. All right? It says, quit. Attempted calculation contains division by 0. So, of course, we knew that. We flip 0 around, gives you 0 on the bottom, which is a problem. So, what about the secant? Does not exist. Very good. And cotangent, we flip around 1 over 0. We're going to get 0. Okay? Again, if you wanted to check it, when you get this, you could go to an error and see what happens, and they'll say, okay, this is the problem. All right, let's just clear. Okay, I'm going to go back to degree mode just for a moment, maybe. Okay, I'm going to go to degrees. Okay, and then I'm going to do 1 over where was I? Tangent of 1 over tangent of 90, because I'm degrees. So there we go. Still says error. Okay. So what happened? Tangent of pi over 2 isn't letting you do that. Does that mean that cotangent is undefined? Do you see what happened here? We flipped around something that doesn't exist. They're saying this doesn't exist, but we know better, okay? Because we can flip it around and it's good. But if you were going through tangent, you can't say, oh yeah, that exists if you flip it around. Well, the calculator figures it out first and then flips it. So that's why it's going to tell you that. Okay. So let's try pi. Go away. Okay. Where's pi in the unit circle? 180. That's right. 180 degrees. The terminal ray looks like this. Right there is P or whatever. What is the ordered pair at P? -1, 0. Okay. So here we go. Sine of pi, cosine of pi, tangent of pi, cosecant of pi, secant pi, and cotangent pi. Alrighty. Okay, let's see. Allie Rivers, sine of pi. 0. Very good. Cosine of pi. Megan Cook. Very good. Tangent of pi. You bet.
-1. Wait. 0.
Sure about that? Change your mind again. Come on, it's y over x, right?
Yeah.
0. Final answer?
Yeah.
Okay, good job. Good job.
Good job.
All right, good job. Good job. Okay.
Good job.
What about Jillian, cosecant? Which one are you flipping around?
First one, so yeah, it doesn't make sense for me.
That's you talk yourself into it. Right?
You can't flip 0 over 0. That's just.
Well, first of all, this isn't 0 over 0 over anything. 1, technically.
Okay.
Okay? Because it's never going to be over 0. All right. Mackenzie, what about secant pi?
I don't know.
What are you flipping around?
So 0.
Whatever the cosine pi.
So number 1.
Negative 1. Okay? All right? Again, brand new material. You got to process it. Make sure you understand it. Cotangent of pi. Lindsay, what's that? Say it again. Sometimes yes, you're flipping 0 around. That's problem. Very good. Okay? All right. Quadrantal angle 3 pi over 2. How many degrees is that? 270. So the terminal ray would be right here. Ordered pair is 0, negative 1. Okay. Alrighty here. Sine of 270. 3 pi over 2. I'm just trying to get used to looking at these radians here. Bless you, bless you, bless you. Tangent of 3 pi over 2. All right. Times here. Okay. All right. And then we do cosecants. Get in the habit of writing them the same way. That's how you remember them. We'll talk when you're writing secant 3 pi over 2 and cotangents. All right, Holly, what's the sign of 3 pi over 2? Negative 1, very good. Sarah, what's the cosine of 3 pi over 2? 0, very good. So you're talking about y, you're talking about x. Okay, I don't know why they don't do these alphabetically, but that's how we're so the total was. So that's why you do sign first, we always do. Okay, tangents, Mr. Merck does not exist. Y over x is problematic with 0 on the bottom. Very good. Aaron, what about cosecant of 3 pi over 2? Just 1 over the sine of 3 pi over 2. Negative 1. Okay. What about the secant, Catherine, of 3 pi over 2? Does not exist. Very good. Molly, what about the cotangent of 3 pi over 2? Very good. Okay. You didn't have any numbers, but remember, you must have had 0 on the bottom, so now you have 0 on the top. Okay. You can, if that's confusing to you, then you have to remember x over y as opposed to y over x. Okay, and then you can do it that way. If that's confusing on your DNA. Okay?
On your what? So does not exist.
Does not exist. Meanings. Okay, because it's like whenever you're flipping around, we don't have anything to flip. All right, girls. Brain break.
Oh,
What? You have 5 minutes? Okay. So what are you going to do?
Can you give us the number so we can start to scan?
Yeah, let me get it. Okay, so we have, yes, we have more to do, but basically, here's where we're going to start with our special right triangles and then get into all that. We're going to get into some special things. But for now, we're looking at, don't forget to drop your point. Oh, yes, thank you. Okay.
Just as